So today's algorithm challenge was to implement a naive search algorithm. The way I created my version of a naive search algorithm is basically I created this function that's going to check if this word that I provide as a second argument is present in our first argument here. So for instance, here I have the word hello, and this function here called native is going to check how many times the word hello is present in our first argument. So here I created the variable called counter. I created a for loop that's going to iterate over our first string here, and inside this for loop we have a nested for loop that's going to iterate over our second string. It's going to check if our letters are equal to each other. If they are not, it's going to reinitialize our variable j back to 0. Else, if they do match each other, I want to increase I by 1, and so it could also keep up with our variable j that's getting updated every time. And then eventually we're going to hit this if statement. If j equals the length of our string here, minus 1, it's going to increase our counter variable by 1. So just to prove that this does work, our counter should equal 2 because we have the word hello twice being passed into this function. So let's do that. As you can see, I have it already. We're just going to paste it again. Delete everything we have. We're going to paste it here, visualize execution. Okay, so as you can see, it's steps 1 out of 268. We're going to go all the way to the end and let's go back one step. Return value is 2. So we know that this code does work when we pass in these parameters. This is a very useful site, by the way. It's called pythontutor.com. Just change it to the language that you're using, and it's very informative, and it shows you how your function is working behind the scenes. Or not behind the scenes, but it gives you a more detailed version of what it's doing. Okay. But as you can see, it's my code's going through a lot of steps, and it's also very not concise, and a lot of people would say it's not very easy to read. So one of the alternate solutions that I found while taking a Udemy course, specifically the course on algorithms and data structures, this was the solution that was provided. As you can see, it's a lot more concise and a lot easier to read. And if we copy and paste this into Python Tutor, it's steps 1 of 71, but we're giving it 2 different arguments. Let's pass in our arguments that we gave for our first function. So let's edit this code and give it the same arguments. There you go. So my code was around 278 steps. This is way less than that. So as you can see, it's a much better solution than the one that I provided. So what I also want to do was show you what this code's doing. So again, here we're calling the function called naive search, and we give it these 2 parameters below, where we give it our first string and our second string, and here they're being called long and short. So let's forward. Okay, we start executing the code now. So our long parameter is this string here. Our short parameter is hello. Count is initialized to 0. Okay, we are in the for loop now. I is 0. And then we go to our nested for loop where j is equal to 0. Let's zoom out a bit. Okay. Then we get to this if statement here is is short j, which right now is equal to 0, not equal to I plus j. So right now I is 0. So basically is h equal to this h here? It is. Okay, so we're going to move on to our line number 6. Is j equal to short dot length minus 1? So is it equal to 1, 2, 3, 4, 5? But because we subtracted 1, is it equal to 4? No, right now j is equal to 0, so this count plus plus is not going to get executed. Okay, we go back up to line number 4, which is our nested for loop. J gets increased to 1. Okay, we go back down where this if statement gets executed again. Is short j, which is now e, equal to I plus j, which is 0. So is e equal to 0 plus 1, so h. So it's e equal to the letter to our second h here. It's not, so that's going to execute this break here. Okay, so we go back to our first for loop and increase I by 1. We reach our nested for loop, which again gets reinitialized to 0, and then we hit this point here. So is short j, which again is the letter h, not equal to 1 plus 0, which is 1. So is our letter h equal to this h here? It is, so we should keep on going. We go again to line number 6, where it sees if we reach the end of our second string here. We haven't. Okay, that's going to increase j. Okay, we go again to the if statement. So again, it checks if j, which is right now is 1, so the letter e, is it not equal to I plus j, which is now 1 plus 1. So 1 plus 1 is equal to 2. So now we're checking if e is equal to our index of 2 over here, 0, 1, 2. In this case, it is. And we're just going to keep on going. Right, we've already increased count plus plus, or we've already increased count by 1. And that's basically how this function works. It's a lot more concise, it's a lot faster. Everything seems to seems to work a lot better than my monstrosity up here. But nevertheless, I'm happy that I made it work.